If your RAG is failing, you need to know where. Retrieval or generation. We'll measure retrieval recall and answer faithfulness so you can debug the pipeline instead of guessing. Maybe your system returns plausible-sounding answers that invent facts. Maybe it misses simple facts because the retriever never found the right document. By the end of this video, you will know how to separate those problems. You will measure retrieval recall and whether answers are faithful to retrieved context. That gives you a targeted place to fix things. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. RAG evaluation sits at the intersection of search and language generation. In practice, people use it when a model answers from external documents. The hard part is that errors can come from two places. The retriever can miss relevant passages, or the generator can invent content not supported by what it was given. Success means the retriever finds the needed passages, and the generator uses them. Measuring both lets you act, not guess. At a high level, we track two ideas. Retrieval recall measures whether the retriever returned any relevant documents. Recall at 2 means did the correct document appear in the top 2 results. Answer faithfulness measures whether the generated answer is supported by the retrieved context. Think of faithfulness as a yes or no about sourcing. Both are simple to compute on small test sets, and they scale to larger corpora. Concretely imagine a single question and a tiny corpus. We will retrieve the top documents, check if the known relevant document appears, then build an answer from the retrieved context and test whether the answer cites or repeats evidence from those documents. The strengths are clarity and targeted debugging. The weakness is that faithfulness estimation can be brittle if you only use token overlap. But it makes a strong baseline. We will build a stepwise baseline. First, we will retrieve by simple token overlap. Then we will compute recall at 2 using a small relevance set. Next, we will assemble an answer from the retrieved context and score faithfulness with overlap. Then we will increase the top k to 3 and recompute recall. Finally, we will combine recall and faithfulness into a tiny baseline metric you can compare across runs. This keeps each step focused and interpretable. This snippet retrieves the top 2 documents using simple token overlap. This snippet shows a tiny retriever that counts shared words between the query and each document and picks the 2 highest scoring items. The core idea is simple, matching for a quick sanity check. T-lines split text into tokens, compute an overlap score for each document, sort by that score, and then return the top 2. That top 2 is the adjustable part you might change later. If you increase it, you give the generator more material but also more noise. For a baseline, this method is fast, easy to inspect, and great for seeing whether the right document is even reachable with basic matching. Next, we will measure retrieval recall against a relevance set. This snippet measures retrieval recall at 2 against a small relevance set. This snippet computes recall at 2 by checking whether any known relevant doc ID appears in the retriever results. The central idea is to treat relevance as ground truth and ask a simple question. Did the retriever include a relevant document in the top 2? Key lines load a small relevance mapping, run the retriever from the previous step, and then compute the fraction of queries where the relevant ID was present. Changing the k would change recall, and a higher k usually raises recall at the cost of inspection and potential noise for the generator. This metric tells you whether retrieval is the likely failure point. Next, we will build an answer from the retrieved context and score faithfulness. This snippet built an answer from retrieved context and scores faithfulness. This snippet concatenates the top 2 retrieved passages, prompts a generator to produce an answer from that context, and then scores faithfulness by checking how many key tokens in the answer appear back in the retrieved text. The idea is simple. An answer is faithful if its factual tokens are present in the sources. Key parts assemble context, call the generator function, extract important tokens or phrases from the generated answer, and compute an overlap score with the concatenated retrieval text. The overlap threshold is the important parameter here. A lower threshold flags more answers as faithful, but risks missing subtle hallucinations. This gives a practical, interpretable faithfulness signal. Next, we will increase the retrieval size and reevaluate recall. This snippet increases top K to 3 and recomputes retrieval recall. This snippet repeats the recall computation, but returns the top 3 documents instead of 2. The central change is a single parameter, top K. Key lines mirror the earlier retriever code, but pass a value of 3 to the selection routine. Then, measure recall at 3 against the same small relevance set. Increasing K usually improves recall because you have more chances to include the relevant document. But it also increases the chance the generator sees irrelevant text, which can harm faithfulness. Comparing recall at 2 and recall at 3 gives a clear signal about whether more aggressive retrieval helps or just adds noise. Next, we will package both signals into a single baseline metric. This snippet packages recall and faithfulness into a tiny baseline metric. This snippet takes the retrieval recall value and the average faithfulness score and combines them into a single baseline number. For example, by averaging or multiplying the 2 components. The core idea is to give one figure you can track across changes. Key lines compute the 2 signals, normalize them so they sit on the same scale, and then produce a combined score. If you change how you combine the numbers, you change the interpretation. Averaging treats both aspects equally. Multiplying penalizes cases where 1 is near 0. This baseline helps you compare retrievers and generators quickly. In a real project, you would map this toy flow to your full corpus. Swap the token overlap retriever for a vector index and collect a labeled relevance set for a more robust recall estimate. You would also refine the faithfulness check with named entity matching or entailment models for better precision. Recap. This method measures 2 things, retrieval recall and answer faithfulness. Use it when you need to know if errors come from search or generation. Caveat. A simple overlap faithfulness test is a baseline and can miss paraphrased support. Next step. Scale the retriever to an approximate nearest neighbor index and rerun the same recall and faithfulness measurements to see how much retrieval quality helps the final answers. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.